Hi everybody. I know we left class in kind of a rush the other day, and since I'm not here today and you have a quiz next class, I wanted to go over just a couple things so that you were prepared to be able to study over the next couple days. We left off class working on example 8 from your day 3 notes. So if you open up your notes and you find that very last example that we were working at from last class, this should look familiar. Now, we started with this cubic here, and we looked at a table in our calculator in order to find what one of the integer zeros was. And we found that when x equals 1, y equals 0. So that tells us that x equals 1 is a root or a factor, is a root or a 0. And so then x minus 1 is a factor for our cubic equation. In order to figure out what remains when we factor out the x minus 1, we need to use some type of division. So I'm using synthetic division here. If you would rather use long division or use a rectangle in order to figure out what's left, that's totally up to you. As long as you can get to this place right here. So we take our cubic, we divide by x minus 1, and we get 6x squared minus 7x minus 3 left over. Because this quadratic does factor, we want to just go ahead and do so. So you can use the AC method, you can use the diamond method, any way you prefer. We just need to get to our final factored form here at the bottom, where f of x equals our 3 linear factors, x minus 1, 2x minus 3, and 3x plus 1. That tells us that our roots are what we get when we set each of those equal to 0, or those are also our zeros. Roots and zeros are the same thing. So if the problem asks us to find all zeros, here are our final answers. So that one we'd pretty much finished in class. I just wanted to reiterate that because that could factor, we go ahead and do so. Now, let's say you come across a problem that does not factor, or maybe you can't figure out how it factors. I'm going to give you an additional example here to take a look at. So for this one, I have a new function. We're going to call it g of x. We've got x cubed minus 2x squared minus 14x minus 12. We're going to start the same way we did last time. So we're going to look at this table where we have our x and our y values, and wherever y is 0, the corresponding x value is a 0 of our function. So we know that x equals negative 2 is a 0, or we could call that a root. That means x plus 2 is a factor for our cubic equation g of x. So we're going to use division, and I'm using synthetic again, but one more time, you could use whatever you wanted to, in order to get to this place here where we have our linear factor and then the quadratic that remains once we factor x plus 2 out of the cubic. Now, this one does not factor. So if I try to take just x squared minus 4x minus 6 and factor that, it's not going to work. So I'm going to have to use a different strategy here. And the one I'm going to choose is the quadratic formula. That's pretty much your only option. So you need to recall the quadratic formula. We've got x equals negative b plus or minus the square root of b squared, and you want to make sure you square the negative as well, minus 4ac, all divided by 2 times a. And we expect that in pre-calculus you remember the quadratic formula and you remember how to use it. So here's kind of a crash course quickly where you would get to once you simplify the determinant, what's underneath the square root. You should get positive 40. We want to simplify that square root into 2 root 10. And then we're going to simplify the entire fraction by dividing each piece by 2. So 4 divided by 2 gives us 2, and then 2 divided by 2 gives us 1 root 10. Now that means those are our 2 other zeros that come from the quadratic x squared minus 4x minus 6. So if we wanted to rewrite our entire g of x in factored form, then we would write g of x equals, we know x plus 2 is a factor. Then we know our other zeros, so we had negative 2 is a 0. Our other zeros are 2 plus or minus root 10. So that's 2 other zeros. So now one factor would be x minus the quantity 2 plus root 10, and x minus the quantity 2 minus root 10. Now it looks really messy. It's hard to draw on my iPad. So this would be our final answer in factored form, but if the question says what are the zeros or what are the roots, then just listing these, x equals negative 2, and then 2 plus or minus root 10, those are your zeros. So it depends on what exactly the question is asking. I hope that clears up a little of what we did last time and kind of ties it together. I've also posted a review assignment and an answer key on Moodle if you would like some extra practice problems for your quiz on Friday.